Welcome to Foundations and Pre-Calculus Math 10 with Mr. Johns. Today, we're going to look at section 3.7, and this is about multiplying polynomials. So, basically, if we look at my first example, 1a, we want to expand and simplify. And we have 2n multiplied in brackets by n squared plus 3n plus 5. The important thing is we basically want to multiply everything in this bracket by everything in this bracket. So I'll distribute with arrows like this. So the first multiplication is 2n times n squared. The second multiplication will be 2n times 3n. And the third arrow is 2n times 5. So 2n times n squared is 2n cubed. 2n times 3n is 6n squared. And 2n times 5 is 10n. We'll look for like terms, but in this case there isn't any. So this is my final answer. So in our next example, 1b, we want to expand and simplify again, but here we have a binomial times a trinomial. So it is quite tricky in terms of everything in this bracket times everything in that bracket. What I'll do is I'll take the 3t and I'll multiply it by everything into the bracket, just like above. 3t, 3t, 3t. So I'll have 3t times 4t squared plus 3t times 5t plus 3t times 6. For the negative 2, I'm going to multiply it by everything in the bracket, also using arrows, giving me negative 2 times 4t squared, negative 2 times 5t, and negative 2 times positive 6. So 3t times 4t squared will give me 12t to the power 3 plus 15t plus 18t minus 8t squared minus 10t minus 12. And you'll notice now I have a t cubed, a t squared, and here I have 3 t's. Those are all like terms. So 12 t cubed, I want to do minus 8t squared, and then I'll take my 15t plus 18t minus 10t, gives me positive 23t minus 12. And there's my answer. So go ahead and try your turn number A and B. Good luck. See Mr. Johns if you need help. And now for example 2A, we're going to try another one, and this time we're going to verify our answer is correct using the value x equals 1. So we have a binomial times a trinomial. First thing I'm going to do is multiply the first term in this binomial by all the terms in the trinomial. So x times 3x squared plus x times negative 6x plus x times 1. Then I need to do a second term in the binomial times everything in the trinomial. So minus 2 times 3x squared minus 2 times negative 6x and negative 2 times 1. So x times 3x squared is 3x cubed. X times negative 6x is negative 6x squared. X times 1 is plus x. Negative 2 times 3x squared is negative 6x squared. Negative 2 times negative 6x is positive 12x. Negative 2 times 1 is negative 2. Looking for like terms, I have x squared terms and I have x terms that need to be combined. So 3x cubed, negative 6x squared and negative 6x squared is negative 12x squared. Positive x and positive 12x is plus 13x and minus 2. So we have 3x cubed minus 12x squared plus 13x minus 2 as our expanded solution. Now, if I want to verify my answer is correct using x equals 1, I'm going to check using x equals 1 to verify that the left side and the right side are equal. So I set up myself a nice little chart. My left side is what I started with, x minus 2 times 3x squared minus 6x plus 1. My right side is what I got as a solution, which is 3x cubed minus 12x squared plus 13x minus 2. And now I need to take x equals 1 and put in the value of 1 for each x. I use brackets to make sure I don't make any mistakes. And 1's a good value to use because when you have squared and cubed terms, it doesn't get too big. So 1 minus 2 is negative 1. 3 times 1 squared is 3 times 1, which is 3. Minus 6 times 1 is 6, plus 1. Negative 1. 3 minus 6 is negative 3, plus 1 is negative 2. Negative 1 times negative 2 is positive 2. And now I'll plug in x equals 1 for the right side, and I'm hoping it equals positive 2 as well. If it does, then my answer was correct. Three times 1 cubed is 1, so that's 3. 1 squared is 1, so this is 12. Plus 13 minus 2. 3 minus 12 is negative 9. 13 minus 2 is 11. Negative 9 plus 11 is 2. So this left side equals the right side, which means this is correct based on this. So I've verified my solution. And now you can do the assignment where you'll expand A, expand B, and then you'll expand these two and also check your solution using x equals 1. Good luck!